21. Block A of mass m is at rest on top of block B of mass big M when a horizontal force of magnitude F is exerted on block A for a time delta t as shown in the figure. Block A moves across block B. The coefficient of friction between blocks A and B is mu. There is negligible friction between block B and the surface. Which of the following is a correct expression for the acceleration of block B? Since we are asking about acceleration and there are forces involved, it is always a good idea to try a free body diagram technique. Now in this case, if we consider first block A, we see that obviously there is an applied force moving it forward, and they tell you that there is friction between the two blocks. So there must be a kinetic friction slowing block A down. There is also the obvious gravitational force, and then there is the normal force. We are going to call this normal force 1 because there is going to be another. Talking about equations, this means that the applied force minus mu times the normal force 1 is equal to lowercase m times the acceleration of block A. On the other hand, there is no acceleration in the y direction, so normal force 1 minus mg has to be equal to 0, which means that the normal force 1 is equal to the weight of block A. Now we move on to block B, of which we want to know the acceleration. In this case, we have the gravitational force, capital M times G, and then the ground is exerting a normal force that we can talk about as normal force 2. Because of Newton's third law, if the friction force is to the left for block A, then it must be to the right for block B. And so what we have here is that there is a kinetic friction equal in magnitude and opposite in direction. However, there is no friction between block B and the ground. And so this is the only force acting in the forward direction. Finally, there is also a normal force 1 here, which is actually the one of which the friction force depends. The normal force 2 doesn't affect the friction because it is in the interface between block B and the ground. So, when you talk about the equations for block B, we have that the friction force, kinetic friction, is equal to capital M times acceleration of B. Now, this friction force has to be equal to mu times normal force 1. But normal force 1 has to be equal to little m times g. So mu mg is equal to big M times the acceleration of block B. Acceleration of block B is then mu lowercase m g divided by capital M, and that's option